Hey guys, hope everybody's doing well. It's good to, well, I guess not see you, but talk to you. If you watched the previous videos that Mr. Penner put together, he was showing you, and he's here by the way, he was showing you or reminding you how to factor. And so today what we're going to do is graph by factoring. So we're going to graph, I've got 3 examples for you, so we're going to go through these right now, okay? So if you take a look at what I have, okay, I've got a couple of equations. We'll focus on the top one first. So we have a nice equation here. The A value is 1, so it factors quite nicely. You can set up the diamond if you want to, or you can do it mentally like Mr. Penner showed you, but you're still using the same thought process, okay? Since it's an A value of 1, I know I have X and X. And so what I need to do is figure out what can I multiply to get a -8 and add to get a 2. Well, my students, you'll remember that I tell you, if C is negative, that you are not actually finding a sum, a difference. And so I want 2 numbers that multiply to get 8, and they're 2 units apart. So that's obviously going to be a 2 and a 4. Since the B value is positive, I want the bigger number to have a plus with it. And now we have a nice factored form. And so we're going to center around the vertex. Now, in order to find the vertex, if you remember, we need the axis of symmetry. And the axis of symmetry is going to be the average of our zeros. So we know that if we set these both equal to 0, we're going to get a positive 2 and a -4. So if I take the average of these, I have 2 plus a -4 over 2. So my axis of symmetry is going to end up at a -2 over 2, so -1. Okay. Now, we need the y value to go along with the axis of symmetry to find the vertex, because we know the vertex is going to be on that line. So if I take this and plug it back in, I will find the y. So if I plug it right back here, I'm going to get y equals -1 squared plus 2 times -1, and then -8. So I've got a -10, positive 1, y equals -9. So my vertex is going to be located at -1, -9. So that's going to be, get my glasses. Let's see, -1, -9, so it's going to be located right here. And now we're going to create a table, and we can either graph from this point with the 1, 3, 5, 7 pattern, or we can create a table. And if we're going to create a table, I'd like to see 3 points on either side of the vertex. So I'm going to place my vertex here. And I want 3 points on both sides. So I'm going to have a 0, 1, 2, -2, -3, -4. We should see symmetry in this table. If we don't see the symmetry, something went wrong. Now, 0 is nice because that's my y-intercept. So I've got a -8. And then if I plug 1 in, I've got 1, 2, that's 3, a -5. If I plug 2 in, 4 and 4, that's 8, I get a 0, which shouldn't be a surprise because that was one of our zeros that we saw up here. And then if we plug -2 in, I get a positive 4, -4, those cancel, -8. Looking pretty sweet so far. Plug -3 in, I get 9, and then I get a -6, so 3, -5. And again, we know that this is a 0, so we have a beautiful table right there. So we can use this table to graph, or like I said, we could think of our 1, 3, 5, 7 pattern. Since A is 1, the pattern is going to remain 1, 3, 5, 7. So over 1, up 1, over 1, 1, 2, 3, over 1, 1, 2, 3, 4. That's beautiful because we just hit the x-axis and over 1 up 7, so we're going to be right there. Reflect, so right there. 1, 2, 3, 1, 2, 3. Perfect, -4. And then we flip this over, and we've got it. Draw in your parabola. Make sure you have arrows at the end indicating that it goes on forever. Okay, so that was a pretty nice equation. Now I also set up a Desmos slide. I would encourage you to use it, and you'll be able to check your work. So if you open this up, you can see the table and then also the graph. Either I got lucky or I was pretty good. I'm going to go with luck on this one. All right, so you can see the points pop up if you hit those. Okay, so let's try the second example. So for this one, okay, let's move this up a little bit. All right, so for this one, we see an A value of -2. Now what that tells me, and hopefully you remember this, that graph is going to grow twice as fast as the parent, but it's also going to flip it over, so it's going to open down because of the negative. Now, if you look at all these numbers, I can factor that -2 out. And so I'm going to go ahead and do that right now. So I get a positive x squared, a negative 12x, and a positive 32. So now I'm going to use my diamond, or at least my thought of diamond, on this part and factor it. Oops, put that as A. So let's go y equals -2. And I'm going to have an x and an x. Now, my product is positive, which tells me the 12 truly is a sum. They have to have the same sign. And since the 12 is negative, they're both going to be negative. So I need two numbers to multiply to get 32, add to 12. Well, that's going to be a 4 and an 8. So -4 minus 8. And so my axis of symmetry, take the average of the zeros, which would be 4 and 8. And then I'm going to take the average of those two. So x equals 4 plus 8 over 2. So my axis of symmetry is going to be 12 over 2, 6. I'm going to plug that back in. Now, I don't really want to plug it in here. I'm going to plug it in right here because it makes the math so much easier. Y equals -2. I have 6 minus 4, 2. I have 6 minus 8, -2. Well, 2 times 2 times 2 is going to be 8. A couple of negatives makes it a positive 8. So my vertex is going to land on 6, 8. Now, we can go through and do the table again, or to shorten it up just a little bit, I'm going to go ahead and just use my pattern to graph. So once I have the vertex, so it's 6, 8, I am right here. I now consider my pattern. So my original pattern is 1, 3, 5, 7. I multiply that by the A value, which A, if you remember, is -2. And so I'm going to get a -2, -6, -10, and -14. So from this point, I'm going to go over 1 and then down 2. From that point, over 1, down 6. Nice, because I know that's a 0. And then from there, over 1, down 10, which takes me right here. I'm going to reflect those. So I am 1, 2, 3 from the line of symmetry. 1, 2, 3. 1, 2, 1, 2. And boom. Sketch in your graph. And Mr. Penner is going to pull up the Desmos, make sure we got this correct. And so question 2. And that looks pretty good. Notice, can you turn on number 1 again? Okay, notice how wide number 1 is compared to number 2. 2 grows twice as fast, which makes it look skinnier. And you can see that, and then the negative flips it over. All right, thank you. So let's go to the third example. The third example, I went ahead and factored it out. Now, if you recall, Mr. Penner had one, I believe the A value was -1. And he said, hey, you still got a GCF. And so you got to factor that negative out to create a positive, which makes factoring so much easier. So I would pull this negative out, and then I would have ended up with y equals negative, and then 4x squared plus 24x plus 27. And then when I factor this, it's advanced factoring again, so you could use the diamond and then the rectangle or the guess and check, like Mr. Penner showed you, and you come up with this. Okay, so now our zeros. Okay, so when I set this equal to 0, I'm going to subtract the 9. 2x equals -9, divide by the 2. And I get x equals -4.5. Okay? And then if I look at the second one, I've got 2x plus 3 equals 0. Subtract 3. And then I have 2x equals -3. Divide by the 2. X equals -1.5. Now, may not look too nice, but actually it's pretty easy, because if you look at this, I've got a couple of negatives with 0.5. So when I go for the axis of symmetry, I'm going to land on a nice value. I have -4.5 plus a -1.5 divided by 2. So looks like I've got a -6 over 2. So my axis of symmetry is going to be at -3. Now, if I plug that back in to get the y value for the vertex, well, I think I'm just going to go ahead and plug it into the original. Okay, so I've got y equals -4 times -3 squared minus 24 times -3 minus 27. Now, when you evaluate this, remember that you square the -3 before you multiply by the -4. Okay, so that looks like 9 times -4, so -36. And then negative, that's positive. So that looks like positive 72 minus 27. Now let's see, -36, -27, that looks like 63, a -63. And so I've got y equals -63 plus 72, which comes out to be 9. So my vertex is going to be located at -3, 9. So I'm going to plot that point. So let's see, -3, 9, right there. And I'm not going to make a table. I'm going to use my pattern, because we're only going to fit a few points. If you notice 4, that's going to be even skinnier than that 2. And it's going to drop. So we're going to see this drops really fast. So my pattern, I got 1, 3, 5, 7. So I hit it with the -4, -4, -12, -20. I think that's going to do her. And so from this point, I go over 1, down 4. And I go over 1 and down 12. So let's see, that's 5, 10, 11, 12. And then reflect. Fill in the graph, and As you've seen before, if I miss it, I just make the point bigger. It's kind of a sloppy point. Okay, and then make sure you throw the arrows on. So if Mr. Penner will bring up Desmos, we can see how we did. Nope.
Wrong one.
Wrong one.
Wrong one. We messed up.
Typed
It's
in
all
the wrong
good.
equation.
Typed in the wrong equation, but we're
Okay.
good.
So if you pretend this is Desmos,
Just look at the screen.
if you pretend this is Desmos, that's it. But hopefully your dot's a little bit smaller. So
It really did work before. Promise.
all right, so you guys take care. Hope this helped, and we'll have another video out for you pretty soon. Bye-bye.